Hi students, in this session we are going to deal with the system metrics for thick lens and the system metrics for thin lens. After deriving the equation for the system metrics for thin lens, we go on to derive the lens maker's formula. So let us begin with the system metrics for a thick lens. So we consider here a lens of thickness T and refractive index mu placed in air. Let R1 and R2 be the radii of curvature of both the surfaces. A ray is incident on the first surface. It travels through the lens and gets refracted out. The ray emerges out from the point B. Now, if X1 and X2 are the um, coordinates of the ray at the initial point A and x2 lambda 2 are the coordinates at the final point, then and the ray travels from A to B, it will suffer, two refractions and a translation. So we have already calculated the system metrics for a ray which undergoes first a refraction, then a translation, and then a refraction. And the system matrix is given by this 1 minus capital D P1 by mu 2, and then capital D by mu 2 minus of capital P1 plus P2 minus capital P P1 P2 by mu 2 and 1 minus capital D P2 by mu 2. This is the system matrix which we have already found out when the ray is undergoing one refraction at the surface of the lens, then a translation through the lens, and then a refraction out of the lens. Now, for a thick lens, you just replace this equation at the position of capital D, you replace it with the thickness of the lens T, and mu 2 is the refractive index of the lens which we have taken as mu. So, you get your system metrics for a thick lens as 1 minus TP1 by mu, and the next term T by mu minus of capital P1 plus P2 minus TP1 P2 by mu 2 and 1 minus TP2 by mu. It's not mu 2, it's mu. So this is the only change. You just replace capital D with the thickness of the lens and replace mu 2 with mu. You get the thickness, the system metrics for a thick lens. But when you go to the system metrics for a thin lens, there is a bit of change. For a thick lens, the system metrics, we have written it just now in this manner. But for a thin lens, T tends to 0. So all the terms involving T becomes 0. So that you get the system metrics as 1, 0, minus P1 plus P2 and 1. So this is our C minus D minus A minus B. That is the system metrics in terms of the cost constants. So comparing between these two, you get small a is equal to P1 plus P2, B is equal to 1, C is equal to 1, D is equal to 1. So here we have already written the system metrics for the thin lens, but we are going to write it in one more form. The system metrics for a thin lens is going to be written in one more form. And when you write it in that manner, in between we derive the lens maker's formula also. I think the lens maker's formula mu minus 1 into 1 by R1 minus 1 by R2 is equal to 1 by S is familiar to all of you, which you have learned in your lower classes. Now, what we do here is we wrote down the system metrics for a thin lens, identified the cost constants A, B, C, D here, and using the condition for the image plane that is minus C D1 minus small d plus A capital D1 D2 plus B capital D2 is equal to 0. You substitute for A, B, C, D here. The Gauss constants that you obtain for the thin lens is substituted here, and you get small a is equal to capital D1 minus D2 by D1 into D2. I think it's already known to you that D1 is our U and D2 is our V. Okay, the image distance V. Now, small a is equal to P1 plus P2. That we have already written it down here from our equation for the system metrics. But now we have got small a is also equal to 1 by D2 minus 1 by D1. So, equate both these. P1 plus P2 is equal to 1 by D2 minus 1 by D1. So, P1 is equal to mu2 minus mu1 by R1. That is the power of the lens or refracting surface. We have already written it in our derivation for the refraction matrix. So this is equal to mu minus 1 by R1, and P2 is equal to mu1 minus mu2 by R2, that is 1 minus mu into R2 in this case. So P1 plus P2 is equal to mu minus 1 into 1 by R1 minus 1 by R2 is equal to 1 by D2 minus 1 by D1, which is 1 by V minus 1 by U. We know that when U is at infinity, B is at the focus. When the object is placed at infinity, image is formed at the focus. So 1 by V minus 1 by U is equal to 1 by F. So we get P1 plus P2 is equal to mu minus 1 into 1 by R1 minus 1 by R2 is equal to 1 by F. Now this 1 by F is equal, this is our lens maker's formula. This is equal to 1 by F is equal to P1 plus P2. So we can modify the system metrics for the thin lens too. So the system metrics for the thin lens is given as capital S is equal to matrix 1, 0 minus P1 plus P2 can be replaced as minus of 1 by F and 1. 1, 0 minus 1 by F and 1. So this is the system matrix for a thin lens. So we have written the system matrix for thin lens in two forms, as 1, 0 minus of capital P1 plus P2 and 1, and we have also written it as S is equal to 1, 0 minus 1 by F and 1. And in the process, we have derived the lens maker's formula too. So I hope this class is clear to all of you. If you have any doubts, do contact. Thank you.